Hi, Algebra. We're looking at lesson 6 here, and we're looking at when are equations equivalent. This is also leading us into solving equations. Here we go. In this lesson, guys, 6.3 is going to be the most important part, so we're going to skip ahead to that. In 6.3, Noah's buying a pair of jeans and has a coupon for 10% off. Let's look at this equation right here. We have a value x. We're subtracting 0.1 times x. That's 10% of x. Of means multiply. Plus 270, it tells us that 270 was the sales tax, and we end up with 5670, and that tells it's the total price. So how does this equation represent his purchase? This is the original price of the jeans, x. We're going to subtract 10% of x. So there's our coupon for 10% off. We're subtracting 10% of the original price, adding on our sales tax, and that's how we end up with the total price. The solution to the equation would be finding out whatever x equals right there. And x would end up being the original price for the jeans. B, how can you verify that 70 is not a solution, but 60 is? And we could do that by plugging it in. If I plug in 70 for x into the equation and I simplify it, and I keep going here, I end up with 6575 equals 5670. And that is not a true statement. Those two things are not equal. When I plug in 60 for x, for here and here, and I evaluate this down, I end up with 5670 equals 5670. And so since it makes it true, we know that 60 is the solution, which means that the original price of the jeans was $60. Now we're going to be looking through 6 different equations and deciding if they are the same as our original equation, what was done to the equation, the interpretation, so what does that new equation tell us, and does it have the same solution as the original? In our first equation, equation A, I'm noticing that every term got multiplied by 100 to make our new equation. When I plug in 60 into our new equation and I simplify it down, I end up getting the same thing on both sides of the equation. So yes, this equation does have the same solution. In equation B, they're telling us what was done. They subtracted 270 from both sides of the equation. Notice they subtract 270 here and 270 there. We end up with this. So the interpretation of what this equation tells us is the total cost of the jeans without sales tax, because that 270 was sales tax. And I can see when I plug in 60 to this new equation that I do end up with a true statement. Same thing on both sides. And so yes, this one also has the same solution. Equation C looks a little bit different. We have 0.9x plus 270 equals 5670. So what was done? How did we get from this equation to this equation? And what really happened was we combined like terms. I want you to write this down right here. When it's just x, it really means 1x. And so 1x minus 0.1x means that we still have 0.9x right there. So what was done? We combined like terms. The interpretation here helps it make sense too. 10% off means that you end up paying 90% of the original price. So it's 90% of the original price plus sales tax is $56.70. When I plug in 60 to that equation and I evaluate it through, I can see that I end up with 5670 equals 5670. So yes, this one also has the same solution. Here we can see that in this equation, we subtracted 270 from just the left-hand side, not from the right-hand side. So this means that we're given the price after using the coupon for 10% off and before sales tax is $56.70. So they're not including sales tax in here. When I plug in 60 to see if this has the same solution, I end up with 54 equals 56.70. Those two things are not equal, so this equation does not have the same solution. And that's because we only subtracted 270 from the left side. We didn't do it to both sides. In equation E, they said that they subtracted 270 from the left and they added 270 to the right. So we can see that up here in the equation. The interpretation, this equation would give us the price after using the coupon and before the sales tax was put on there, and it would tell us that that total price was then $59.40. Does this have the same solution? I plugged in 60 to the equation, and when I evaluate that through, I get 54 equals 59.40. Those two things are not the same thing, And so this would not have the same solution. And the big reason why is that they subtracted 270 from the left and they added 270 to the right. Remember, we have to do the same thing to both sides of the equal sign. In equation F right here, what was done, they multiplied the left side of the equation by 2. Notice that nothing was done on the right-hand side. The interpretation, this means that the price of 2 pairs of jeans, because we're going to take all this times 2, after using the coupon for 10% off and paying sales tax is $56.70. Does this have the same solution? So I'm plugging in 60 into the equation, and as I simplify it all the way down, I end up with 113.40 on the left equals 56.70 on the right. These two things are not equal, so no, they do not have the same solution. And looking back at why they don't have the same solution, it's because they only multiplied the left side by 2. They didn't do it to the right side as well. And you got to do the same thing to both sides of the equal sign. I reviewed each equation here with what was done to the equation from the original. So in equation E, we multiplied both sides by 10. Equation A would be equivalent to the original equation. Equation B, we subtracted 270 from both sides. So yes, equation B is equivalent to the original equation. Equation C, we just combined like terms. Remember, that's how we got the 0.9x. So equation C is equivalent. The other three equations, D, E, and F, that's where we only did something to one side of the equation. So in D, we subtracted 270 from only the left side, so it was not equivalent. In E, we subtracted 270 from the left and added it to the right, so it's not equivalent. And in F, we only multiplied the left side by 2, nothing to the right, so that one was not equivalent. So remember, our legal moves to keep things equivalent, we got to do things to both sides of the equal sign, or just combining like terms also keeps things equivalent. Here's a definition to add to your book at the end of the lesson. Equivalent equations are equations that have the exact same solutions. They might not look the same because you did something to both sides of the equation, but they have the exact same solutions.